Hey kids, here's the last lesson for Unit 6. This goes on your list of integration techniques. And you think of this technique when your integrand is a quotient that you might need to integrate by partial fractions. Now, this, just like integration by parts, when your integrand is a product, I don't see a quotient and immediately think partial fractions, right? I think, is it one of my formulas, one of my inverse trig formulas? Is it regular one? Is it 1 over secant that I can rewrite as cosine? Can I do any algebra or factoring, turn it into a U substitution problem? If none of that works, I take a moment and cry and feel sad for myself. But then I think integration by partial fractions might be the way to go. And I remember I took pre-cal and paid attention. And I looked to see if my denominator can be broken into multiple parts. In other words, can I factor it quickly and easily, the good F word? And if the denominators are my parts are degree 1 or degree 2. Integration by parts works when you have higher degrees, but BC is only going to test you on degree 1 or degree 2. So here's my first example. I have a quotient. I wonder if I can factor this quadratic and cancel. No. I wonder if I should do U substitution. If I do U substitution and I put x squared minus 2x minus 3 in a group, its derivative is 2x minus 2. I can't manipulate that numerator into 2x minus 2. So U substitution is not going to work. I can't do integration by parts because if I turn that into a product, I have a product of a composition. That's not going to work either. So again, I take a moment and I cry. I thought I had crying. That's why that little speaker was there to remind me. Does it work? Guess not. Anyway, I look at that quadratic. I took algebra 1 and I paid attention and I factor it quickly and easily. Notice I've dropped the integral sign. I stop calculus and do pre-cal. Now, I don't know at what time of the curriculum honors pre-cal did partial fractions, but I know we did it in IB pre-cal and we did it a lot for this reason. So go back to your notes, your little book, your, practice problems, get familiar, right? Because it has been a while. But I factored this, and my job, what I want to do is rewrite the integrand. I want to take this quotient and I want to use partial fractions to rewrite it. So I'm going to rip it apart. Oh, did you hear that? That sound did come in. Listen. Rip! I'm going to rip that fraction apart. Partial fraction says if I had two fractions without a common denominator, I would create a common denominator and then manipulate my numerators and combine them into one fraction, right? That's just like you do when you have 2/3 plus 5/7, right? You say, oh, the common denominator is 3 times 7, and you multiply the 2 times the 7, and you multiply the 5 times the 3, and you get one denominator and one numerator. I need you to rip this. Could you go backwards? Could you factor 21 into 7 and 3 and then figure out how the numerators, what the individual numerators were? That's all partial fractions is. So now that I have an equation, I'm going to multiply both sides by the common denominator. Now notice I have non-repeating linear factors, degree 1. A and B have to combine to 5x minus 3, just like the 2 and the 5 ended up being a 29. So multiply by the common denominator. I'm going to go through this algebra fast because you are in BC and this was an objective in your prerequisite classes. Distributed, set like terms equal to each other. 5x has to be equal to ax, right? And the bx, right? X terms have to combine. Constants have to combine. Now I have two equations with two unknowns. I'm just going to do algebra 1 and solve the system. Right? Multiplied through by a negative. Add these two together. The a's drop out. I solve for b. And then I resubstitute and solve for a. Now I brought calculus back. I took the integral and did pre-cal on it. I ripped it up into two separate fractions. What is the integral of a sum, though? The sum of the integrals. This is stuff to the first power. And there's my antiderivative. If you don't believe me, what can you do? Take the derivative of this. You'll get separate fractions, and then you can combine them together. This is called integration by partial fractions. It is still rewriting your integrand. Use substitution, rewrite your integrand. Integration by parts, rewrite your integrand. Integration by partial fractions, rewrite your integrand so that you can integrate. Now I'm going to show you, which again, I don't know about the honors pre-cal curriculum, but I know that in IB pre-cal we gave you and we showed you that method for partial fractions, and then we said here's a little bit of a shortcut, right? And after this English mathematician called Oliver Heaviside, which I think is funny because it heavisides the need to solve a system. So I'm going to do the exact same problem. I call it the Annihilation Method. Warning, I do have Arnold, which is movie violence, movie gun, right? Not real guns. Real guns, bad. Turn your sound off if the sound of a gun bothers you. I don't mean it to bother anybody. I'm just trying to emphasize that the Heaviside method saves you some algebra. So I have an equation here after I multiplied through by the common denominator. And since I have an equation, as long as I put x to be the same number, that's a legal move. I choose of all the numbers in all the world to let x be -1. Look what happens. Boom. I terminated A, the terminator, which let me get B is equal to 2 without solving a system. I put that aside. Then I bring Arnold back, but with a different number. This time I plug x to be 3. I terminate B, solve for A, and get 3. Same answer I got before, little simpler math, right? It's called the Heaviside method. I call it the Terminator method or the Annihilation method. That's not my name. I call it the Terminator method. This method does have a name, and it's called the Annihilation method. But of course, remember, after we do that, whatever algebra and pre-cal you're doing, then you bring the calculus back, do the integral of a sum, but with use substitution of a power of 1, and you're all good. Plus C. Let's do another example. Factor the denominator. First, again, of course, I thought use substitution or inverse tangent. I thought a lot of things. Couldn't do it. Factored the denominator. Notice I dropped calculus to do pre-cal. My job is to rip that fraction apart. If you had 3 factors, you know what you would do? You know, whatever it was, that's what you would do. And we did that in pre-cal. We did those cases. In BC, tend not to see them. Tend to just see the double factors. I think some of your homeworks might have 3 factors, right? Just for practice and extension. Multiply through by the common denominator. Bring Arnold to the situation. Who you want to let x be? And you can choose either -2 or 0. I chose -2 first, so who gets terminated? A, bye-bye. And what does B equal? Bring Arnold back. This time, let x equal 0. Terminate B. A is equal to +1/2. Take your integrand and rewrite it. I think I will osmosis the 1/2 outside here. And then the integral of a difference is the difference of the separate integrals. Bam. Done and done. Last one. The degree of the numerator has to be smaller than the denominator for partial fractions to work. So let me go back and verify. Example 2, I had an x to the 0. 0 smaller than 2. Example 1, power of 1 in the numerator, power of 2 in the denominator. The denominator was the most powerful. For partial fractions to work, the degree of the numerator must be lower than the degree of the denominator. If it's not, I just have to do algebra 2. So see how prerequisite material is so important, right? You were taught in an algebra 2 class how to do long division. So divide x squared, right? It's kind of like having 10 over 7, right? Well, you're dividing, right? 7 fits into 10 one time with 3 remaining. That's what I'm doing here. The bottom is not as big as the top, so divide to make it so. If you use partial fractions and you don't do long division first, you will get the fraction part of your answer, but you'll lose the whole part. So look what happens when I divide. What do I multiply x squared by to get 2x cubed? Hopefully you see that's just a 2x. Multiply, subtract, or add the opposite. I got 5x minus 3. My remainder is smaller than what I'm dividing by, therefore that's my remainder. So the result of my division is 2x and my remainder on top of what I was dividing by. Right? That's what you did over here. 7 goes into 10 one time. The remainder was 3 on top of what you were dividing by. Notice I dropped the calculus to do algebra 2. I'm going to keep dropping the calculus, and now I'm going to do pre-cal, because not on 2x, but this part is a fraction that I can't use substitution on or reduce or anything like that. But hey, look at that problem. That's called planning, kids. This is the same problem from example 1. So I already know how this breaks apart. Rip it apart. Drop calculus, did algebra 2, did my pre-cal, bring calculus back. I already know how to integrate that though. So the integral of this big, long, hairy fraction is the integral of its separate parts that I got from division and partial fractions. 2x and 3 over x minus 3 and 2 over x plus 1. I already integrated this from example 1. Integrating 2x is 2x squared over 2. Now I'm done. Again, if you do partial fraction work with this quadratic and this whole numerator, you will end up with this. You just will have lost the x squared. Okay. All right, we will do more example. We'll do another example of that in our next live session.